Today, on How It's Made. Electrical panels. You'll get a charge out of this story. Kites. These handmade models are flying off the shelves. Eyeglass frames. We have a look-see at the metal ones. And toothbrushes. A report that'll have you bristling with excitement. The technical name for it is a residential load center, but people usually call it an electrical panel or circuit breaker box. This enclosed metal panel is usually built into an interior wall. It contains the circuit breakers that distribute, protect, and control the home's lighting and power. This load center consists of up to 40 circuits. Each one has 1 or 2 breakers. Each breaker powers several outlets in the home. First, a powerful press pounds a sheet of steel into what's called a U-channel. At nearly a meter long, 35 centimeters wide, and 10 centimeters deep, it's part of what's called the tub, the load center's main casing. A worker then attaches steel components made earlier called tub ends. A spot welding machine fuses them to close off both ends of the tub. Workers feed an aluminum strip that's 100 meters long and 15 centimeters wide into a stamping press. The press cuts the strip into 50 centimeter long segments called bus bars. It bends each bus bar 10 times, creating 5 centimeter segments called stabs. The breakers will later snap onto these stabs. Next, a worker inserts each bus bar into a plastic component called a base pan. The base pan insulates the bus bar. This prevents us from getting electrocuted. Another press then inserts a plastic rivet, securing the bus bar to the base pan. The worker installs 2 components called neutral bars in the base pan. The neutral bars conduct electricity between the circuit and the wall socket. Next comes the main breaker. Its maximum capacity is 200 amps. Amps are the units of measurement for electrical current. If demand exceeds maximum capacity, it'll trip, meaning it'll turn off all power in the home. She makes sure it's sufficiently tight so that vibrations caused by street traffic won't loosen it. She also encloses labels to mark the breaker's pathways and an envelope with installation screws. Next, the worker puts the base pan assembly into the tub and secures the neutral bar with a copper bonding strap to ground it and prevent electrocution. She adds another component, one of 2 grounding bars. These ground each circuit. The breakers simply snap onto the stabs, making them easy to remove and replace if needed. Inside the breaker, several components interact to enable the flow of electricity. One is the load terminal, the entry point for the live current. A circular machine called Robot A assembles it and other breaker parts along its 16 workstations. Another breaker component is the bimetal assembly. It's an alloy of 2 metals and a magnet. It trips the breaker when there's an overload or short circuit. Next, Robot A welds a strip of silver, which is conductive, to what's called the contact arm. Robot A then positions the arm for welding with 5 centimeter long segments of braided copper wire. Copper because it's conductive as well as pliable. The robot fuses the copper wire to the contact arm and the bimetal assembly. The wire will flex with the arm to touch what's called the line terminal. This contact permits the electrical current to flow. Next, Robot A deposits the welded parts into the breaker casings called bases. This automated production line functions 24 hours a day, 5 days a week, and it produces a breaker every 3 seconds. Another machine, called Robot B, stamps the number of amps on each breaker handle. Then it connects a spring to link the contact arm to another part called the cradle. When there's an overload, the bimetal assembly causes the cradle to pivot and trip the breaker. Robot B deposits the spring and cradle into the base, then closes the base with a cover. This demonstration shows how moving the breaker handle triggers the mechanism that will enable the flow of electricity. If power demand exceeds the breaker's maximum capacity by 35%, the bimetal assembly trips the breaker and cuts the power. They cap off the load center with a metal cover called a trim. The warning label on it provides safety information and instructions. The load center is now ready for installation by a certified electrician. The earliest written record of a kite tells the story of a Chinese general in 206 BC who flew a kite over a wicked emperor's palace. He marked the line to measure the distance, then reeled it in. His small army then dug a tunnel into the palace courtyard, launching a surprise attack that conquered the emperor. Today's two-line kite, as the name implies, has two lines to pilot it. It can fly nearly 40 meters high. This kite is made mainly of a lightweight nylon fabric that is waterproof and fade-resistant. It's less than 1 millimeter thick, so it's reinforced with nylon mesh to reduce ripping. The kite's other components include nylon and elastic cords and straps, fittings made of leather, rubber, aluminum, and plastic, and carbon rods. The kite maker starts with a pattern made out of pressed wood. She marks out a piece of fabric and, with a few bricks to hold the fabric in place, cuts it diagonally. In sewing terms, that's called cutting on the bias. This will stretch the fabric and help it fly. Next, she cuts more pieces of fabric, this time in a different color. This kite has 8 fabric parts that fit together like a puzzle to create a 2.5-meter wingspan. The kite's left and right sides are mirror images, so there are only 4 different shapes to cut. They range in length from 25 centimeters to 1.2 meters. From start to finish, it takes one worker about 2 hours to make this model called the Dragonfly. First, the kite maker sews the longest part, called the belly, to the other parts. She double stitches with heavy-duty nylon thread to help the kite withstand winds of up to 35 kilometers an hour. She makes tiny incisions along the belly's curved edge so she can fold it and sew in what's called tension line. Tension line is a type of nylon cord she'll sew into all the seams of the kite's lower sections. It'll give the kite some structure and help keep it rigid while airborne. The kite maker secures each line with a knot, which can later be loosened or tightened to adjust the kite's overall tension. The kite maker uses straps made of very durable yet flexible plastic to line the middle and the edges of the wings. The straps strengthen the kite, enabling it to survive crashes into trees and rocks. After all, what goes up must come down. Next, the kite maker sews a piece of leather called a fitting onto the plastic strap. It's made of leather to protect the kite's structural joints, such as the nose of the kite. It gets a leather patch as well. The kite maker uses a serrated saw to cut the 10 carbon rods to size. They're 6 millimeters in diameter and range in length from 18 to 81.5 centimeters. They form the kite's skeleton, and like bones, they're the most likely part of the kite to break in an accident. But if they do break, it's easy to replace them. A variety of molded plastic, rubber, and aluminum fittings serve a dual purpose. They join the rods together and keep them from falling out of their sleeves. Now the kite maker attaches a nylon cord called a bridle to the fitting that joins the rods on the wing's leading edge. The bridle is the kite's rudder, steering the kite to the left or right. The bridle comes off easily if you need to replace the rods. The kite maker now attaches tension lines to 2 plastic components called arrows. They're located at the kite's wingtips. She ties elastic bungee cords through the arrows to hold the tension lines in place. This makes all the fabric parts taut enough to fly. Next, she attaches the bridle to the center rod, the spine of the kite. She inserts the rod into its protective leather pouch at the nose. She inserts other rods into both sides of the wing. These give the wing its curved aerodynamic shape and help the kite stay aloft. Finally, additional rods under the wing provide more structure and support. These rods spread the kite and help keep it open. In the mood for a sky-high experience? For $250, you can buy a handmade model like this one and go fly a kite. Eyeglasses don't merely correct vision, they're also a fashion statement, so much so that many of today's top clothing designers produce a line of eyeglass frames. Whether you prefer plastic frames or metal ones, they come in so many different colors, sizes, and shapes that you're guaranteed to find a pair that suits you. Metal frames come in a multitude of shapes, from ordinary to extraordinary. It all starts with a computerized system called a 3-axis eye winding machine. A set of rollers pulls metal wire from a big spool. Then, with software-driven precision, the machine bends the wire into the shape of the frame, then cuts the end free. The lenses will fit into pre-cut grooves on the inside. A small part called the insert connects the two ends of the eye frame, holding them closed around the lens. To attach the insert, they put it in a clamp, then position the eye frame just above it. They apply a cleaning agent called flux, then filler wire. An electric current heats the wire, metal frame, and insert until they all melt and fuse together. Now they do the same to what's called the screw hinge, the piece that attaches the arm to the eye frame. Again, electrically generated heat fuses the hinge to the insert. This process, similar to soldering, is called brazing. Now for the bridge, the piece over the nose that joins the two eye frames. A small press bends a piece of metal into the shape of the bridge. Then a worker aligns it with the eye frames in an assembly jig. This ensures the frames are perfectly straight. Brazing again melds everything together. Next comes the piece above the bridge called the brow bar. An automated machine cuts metal wire to pieces the right length, then carves grooves on the ends to enable the brow bar to fit snugly onto the top of the frames. It then bends each piece to the right shape. The brow bar now goes into position. A little flux to remove any dust or dirt that might prevent the metal from fusing properly. Then they brazed a brow bar to the frame. Now come little hooks called pad arms. They hold small pads under the bridge that cushion your nose. A worker fuses the pad arms to the frames using the same brazing process as before. Now for the arms that attach to the eye frames on one end and sit on your ears on the other. The industry calls these arms temples because they're at the level of your temples when you wear the glasses. After stamping the size and company name on the inside, they fuse a hinge to each one and press a plastic sleeve on the other end. They set the arms momentarily aside while they position the lenses in the groove of the eye frame. A screw keeps everything tight and intact. Now they screw an arm onto each hinge. The arms on most models have curled ends that hook over the ears for a more secure and comfortable fit. A special machine called a mechanical cam applies pressure to bend the plastic sleeves to a 45-degree angle. Functional and fashionable, these metal frame glasses are eye-catching. The Chinese invented the first toothbrush around 1600, but it wasn't until about 1780 in England that it became a mass-produced item. Like those that followed, its bristles came from the necks and shoulders of pigs. In the late 1930s, synthetic materials replaced natural swine bristles. These toothbrushes should make you want to flash your pearly whites in appreciation if you consider that thousands of years ago, people used twigs to clean their teeth. Today's toothbrush begins as little plastic pellets. A vacuum sucks them up into an injection mold machine. The machine melts the pellets into a kind of plastic dough, then injects it into a stainless steel mold, forming 10 toothbrush handles at once. The head of each handle has up to 56 holes for bristles. This machine generates 10 handles every 35 seconds. That works out to 27,000 handles in 24 hours. Now they melt blue rubber pellets. They pipe the liquid rubber into the mold with the white toothbrush handles, then press the rubber onto the handles to form a grip. So now you have a toothbrush you can really hang on to. No dropping this one in the sink. They use this semi-clear plastic to produce another type of grip, one that's softer and more pliable. It's called the gummy brush because the grip really does feel a bit like one of those gummy candies. These nylon fibers will form the bristles. A robotic arm pats them down so that they sit very evenly. Then, faster than you can blink an eye, the machine feeds the bristles into the holes in the head of the toothbrush handle. This machine works at a blurring speed, filling 900 holes per minute. And it operates with incredible precision. Here's the bristle selection process in slow motion. The machine selects between 22 and 24 bristles for each hole in the brush. With 56 holes per toothbrush, that adds up to over 1,300 bristles for each brush. This fully automated system works faster than any human ever could. And here's another advantage. A human hand rarely has to touch the bristles, so the process is incredibly hygienic. Wondering what holds the bristles in place? Wire. The machine bends the fibers in half, anchoring them to the brush with wire in the middle. Now it's time for a brush cut. These blades trim the bristles to about the same length. Another set of blades sculpts different types of edges, depending on the toothbrush model in production. These may look like spinning tops, but they're rotating discs coated with diamond dust, a mild abrasive. They sand the edges of the bristles to produce a particular finish. For instance, the bristles can be straight or zigzagged. Different finishes have different tooth cleaning effects. You may have noticed that some bristles are white and others are blue or another color. This is purely aesthetic, a nifty color combination to make the toothbrush look smarter. And of course, the machine knows exactly which color goes where, so you end up with a two-toned brush like this one. Every so often, the factory pulls a toothbrush off the assembly line for a spot check. A robot arm tugs at the bristles to make sure they're secure enough. And if the brush passes the test, the rest of the production run is cleared for sale. Then a robotic system packages the brushes so they come right off the line, ready for shipping. And ready to maintain toothy smiles everywhere. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.